Section 5.5 Interactive Assignment, Objective 5. The grade appeal process at a university requires that a jury be structured by selecting 5 individuals randomly from a pool of 9 students and 13 faculty. For Part A, what is the probability of selecting a jury of all students? For Part B, what is the probability of selecting a jury of all faculty? And for Part C, what is the probability of selecting a jury of 2 students and 3 faculty? So we're going to start with Part A. We want to find out what is the probability of selecting a jury of all students. Now recall that according to the classical method, if an experiment has n equally likely outcomes, and if the number of ways that an event E can occur is m, then the probability of the event E is given by the following formula. The number of ways that event E can occur divided by the number of possible outcomes. Okay, now the first step in solving this problem is to find the number of possible juries. To do this, disregard whether an individual is a student or faculty member and treat the jury pool as a whole. In this pool, the individuals are all distinct, so each person will be chosen only once per jury, and the order in which they are chosen does not matter. Given these facts, the situation lends itself to counting by combinations. So what we're going to do here is the following. We know that the total number of students and faculty in our problem is adding them together, meaning that n is going to equal 9 plus 13, which is 22. So therefore, n in our problem is going to equal 22. Okay, and we know that a jury needs 5 jurors. So that means that R is going to equal 5. So now we're going to go ahead and then solve. Okay, we know that we have 22 factorial divided by 5 factorial over 22 minus 5 factorial. So we're going to do what's inside the parentheses first, because 22 minus 5 gives us 17 factorial, which then leads us to tell us in the numerator, we just need to go to 17 factorial. So we go 22 times 21 all the way to 17 factorial. And what this allows us to do is that we can simplify that 17 factorial to 1. Okay, the next thing we need to do is see if we can simplify anything else in the denominator and numerator. Well, if we multiply 5 times 4, that's 20. So that's going to go into the 20 in the numerator, which makes that a 1. And then we also know the following. We know that this 3 times 2, which is going to give us 6, goes into 18 3 times. So what's left to multiply other than 1? Well, we know that we have 22 times 21 times 19 times 3. And when we multiply that together, we get 26,334. This is the number of possible juries, the total number of possible juries. Okay, now the second part is we want to find the number of possible all-student juries. And the number of ways an all-student jury can be chosen is given by letting only the students be the current jury pool and counting the number of possible juries. Now the student-only jury pool has, in our question, a total of, let me see if I can get this in here. We know that there's a total of 9 potential jurors. Given that the jury needs 5 members, okay, what we're going to do is we're going to use the combination formula to calculate the number of juries that can be made from only 9 students. So we're going to use the factorial for the combination. So we know that there's a total of how many students? There is a total of 9 students. And a jury needs 5 jurors, which is R is equal to 5. So we know that N is going to equal the following. It's going to equal 9. So we know that N is going to equal 9. So we're going to place N to be 9. And we know that R is going to be 5. Okay, so what we're going to do is we're going to take 9 factorial divided by 5 factorial times 9 minus 5 factorial. Remember that 9 minus 5 is 4. 4 factorial is 4 times 3 times 2 times 1. We have this 5 factorial and this 5 factorial. So we can simplify those two. So we're going to go ahead and simplify them. So we know that that's going to become 1. Okay, now we know that we can see here that 4 is going to go into 8 2 times. And we know that 3 times 2 is 6 is going to go into 6 1 time. So what we have remaining is the following. We have 9 times 2 times 7 over 1. And 9 times 2 times 7 is going to give us 126. So 126 is the number of juries with only students. So now we're going to use the classical method to find the probability of selecting an all-student jury. Now, excuse me, the probability of finding the jury is all students, we know that the number of possible juries was found in the first part, which is 26,334. Okay? And we also know that 126 is the number of juries with only students. So therefore, when we find that probability, we're going to divide that, and they want us to round it to 5 decimal places. So therefore, 0.00478 is the probability that an all-student jury is chosen. Okay, next we want to find what is the probability of selecting a jury of all faculty. Now, to find the probability that an all-faculty jury is chosen, we're going to follow a similar procedure as the previous step. There are 13 potential jurors for a faculty-only jury. Given that the jury needs 5 members, we're going to use the combination formula to calculate the number of juries that can be made from only the 13. In this case here, we know it's going to be 13 faculty. Okay, so what are some things that we need to know? We know we're going to use our combination formula, like we stated. Okay, so what is the total faculty? Well, we know that the total faculty is n is equal to 13, which we know is 13 faculty. We also know that a juror needs 5 jurors, so we know that R is going to be 5. So let's go ahead and then plug that into our formula. We know that n is going to equal 13. Okay, and we also know that R is going to equal 5. Okay, so we have 13 times 12 times 11 times 10 times 9 times 8. Now the reason why we stop there is because 13 minus 5 is 8, so we can simplify that. And then we're going to expand the 5 factorial to be 5 times 4 times 3 times 2 times 1. Now let's do our simplification. Okay, so what do we know? We know that we can simplify the 8 factorial. Okay, we also know that 4 times 3 is 12, so that's going to go into 12 one time. And we know that 5 times 2 is 10, is going to go into 10 one time as well. So what's left over? We have 13 times 11 times 9. So when we multiply that together, we get 1,287. And that is the number of juries with only faculty. So now we're going to use the classical method to find the probability of selecting an all-faculty jury. Okay, so we want to find the probability that the jury is all faculty. So we want the number of juries with only faculty, and we know that, which is the following. We know that the number of juries with only faculty is what we just found, which is 1287. Okay, and then we're going to divide it by the number of possible juries, which we found at the very beginning of this question, which is 26,334. Rounding this result to 5 decimal places gives us 0.04887. Therefore, 0.04887 is the probability that an all-faculty jury is chosen. Okay. Now the last question states, what is the probability of selecting a jury of 2 students and 3 faculty? Okay, now to find the number of possible juries under these conditions, you can use both the multiplicative rule of counting and combinations. We first find the number of ways to choose 2 students, and then find the number of ways to choose 3 faculty. Okay, so we're going to use the combination formula to find the number of ways that 2 jurors can be chosen from the 9 students. So in this case here, we know that n is going to be the total of students. So we know that n is going to equal 9. And we know that we're selecting from 2 because that's the question. We want to find 2 students. Okay? So therefore, r is going to equal 2. Okay? And now what we're going to do is now we're going to go ahead and then simplify. Okay? So we know that 9 minus 2 is 7, so that's 7 factorial. So in the numerator, we just need to go to 9 times 8 times 7 factorial. So we can simplify the 7 factorial. And we also know that 2 factorial is 2 times 1. So now we can simplify 2, which goes into 8 4 times. So now we end up getting 9 times 4, which is 36. Now we want to use the combination formula to find the number of ways that 3 jurors can be chosen from 13 faculty. So now we want to find 3 jurors from 13 faculty. Okay, so we know that n is going to equal 13. Okay, so we know that n is going to equal 13. So that's 13 faculty. So we know we have n, which represents 13 in our formula. And then we know that there's selecting 3 faculty from our question. And if we come back up here, we're looking for 3 faculty. So therefore, r is going to represent 3. And now we're going to go ahead and then simplify. Okay, so by simplifying, we know that 13 minus 3 is 10, so that's 10 factorial, which tells us our numerator just needs to go to 10 factorial. So we can simplify those to 1. And then 3 factorial is 3 times 2 times 1. Well, 3 times 2 is 6, and 6 goes into 12 2 times. So therefore, we have 13 times 2 times 11, which gives us 286. Okay, now what do we do with those 2 numbers? Well, with those 2 numbers, okay, the multiplication rule of counting states that if a task consists of a sequence of choices in which there are P selections for the first choice and Q selections for the second choice, R selections for the third choice, and so on, we would take each one of those choices and multiply them together to get the different ways. So we're going to multiply the number of ways to choose 2 students from the number of ways to choose 3 faculty. Well, recall that we end up getting the following. We got 36 to choose students and 286 ways to choose faculty. So 36 times 286 gives us 1,296. And that 1,296 is the number of ways to choose 3 faculty and 2 students. So now, to find the answer to the last part of this problem, we're going to use the classical method to compute the probability that a jury of 2 students and 3 faculty will be selected. So we're going to find the probability of the mixed jury, okay, we're going to take the following. we know that we need to find the number of ways to choose 3 faculty and 2 students. Well, we know that that's what we just found, which is 10,296. And at the very beginning of the problem, we know that the number of possible juries is 26,334. So now what we're going to do is divide that and then round it to 5 decimal places. And so therefore, we get the following amount, 0.39098. So therefore, the probability of a jury of 2 students and 3 faculty is 0.39098. And if we take a look at our problem here, each one of those is our answers. We see that we get the answer for part A, the answer for part B, and the answer for part C.